For implementing a queue using array, we require following things, that is a fixed size array, and the size also we should know what is the size of an array or a queue. Then also we need two pointers, that are front and rear pointer. So all these things we can combine them together under a structure because all these are related to a queue. So let me define a structure for a queue. Structure queue. So what are the members I need? I need the size. What is the size of a queue? That is size of an array. Then I need front pointer to point upon first element and rear pointer to point upon last element. This is used for insertion and this is used for deletion, front for deletion. Then also I need an array space. So what size it should be? It can be known only at runtime. When really program is running, we can decide the size and create an array dynamically from heap. So for creating array dynamically, I should take a pointer. So I will not declare an array, but I will just take a pointer q for an array. So this I will be creating it dynamically. Now let us see how to create the variable of that type structure and how to initialize it. So I will write on the program code and show you this code. We will be using it wherever required whenever we are using queue. Let us assume that this is a main function, right? Inside main function, I am creating a variable of type that structure queue. This queue is an object of that type structure. So once I create this object queue or variable of type queue, I'll get following members. First one is size and second one is front pointer and the next is rear pointer and q is a pointer to an array. So I am calling them as pointer. These are not actually pointers. These are index pointers, right? So index pointers, those are not address pointers, but they are pointing on the element. So we are calling them as pointers. Don't confuse them with address pointers. So a variable is created, then we have to initialize all these. So first of all, I will find out what is the size. So I will take the size from the keyboard. I will give a message, enter the size of a queue and then take the size. So here a message is enter the size, then scanf, I have to take the size. So size is what? Q dot size, I have to say. Q is the size. So Q dot size. Q dot size. So with this, whatever the size is given, that size will be filled here. Suppose the size is 7. So 7 is the size. Then based on that size, I should create an array of a size 7 and fix it to with this pointer Q. So I should create this array. I should create that array. So for creating that array, I should say Q dot Q. So Q is a variable name and it is having member Q as a pointer of type integer array. This is an address pointer. Then to this, I should dynamically allocate the memory from heap and assign it. So for dynamically memory allocation, we use malloc function or else we can use new. So malloc will create an array and to that Q will be pointing, right? So instead of writing lengthy code, I was preferring writing new, and while typing the program, I am using malloc function. Now the last thing, I have to initialize front and rear. Initially both are -1, so I have to set this as -1 and this also as -1. So say q dot front as well as q dot rear both assign -1. So we can initialize them together in a single statement. So these are the steps required for initializing a queue. Now let us look at functions, operations on a queue. That is, we look at enqueue and dequeue operation. So I will write on the functions for enqueue and dequeue. So enqueue function. Enqueue function is taking a value that we want to insert in a queue and also in which queue you want to insert. So it is taking queue as called by address or called by reference. So if suppose this is the object created in main function or some other function, wherever it is, we want to insert in that queue, then this queue is a pointer to this one, pointer to that particular object. Now let us write the function. For insertion, first of all, we should know is there any space or not. If there is no space, we cannot insert. If there is no space means queue is full. So first check whether queue is full. So I'll write on the condition for queue full. If this is the case, then queue is full. I cannot insert any element. So here simply I'll give a message that queue is full or queue overflow. Queue is full. If it is not full, then we can insert the element. So else, How to insert the element? So for inserting an element, we should move rear pointer one step and then insert the element. That's it. Step is simple. Move rear and insert the element. So this rear I should move, this rear. So Q's rear plus plus. So Q's rear is moved. So Q's rear plus plus. So rear becomes now 0, means it's pointing here. So here in this data structure, if you see, it is 0. So it means it's pointing on index 0, right? Then at Q's 0 position, means Q's rear position, I should insert the value. So Q's Q, so value 12, whatever the value you are inserting, it will be inserted there. But we are visualizing it like this. This is how it happens inside MEM. So that's all. End of the function, end of else part, and end of enqueue. If you look at the steps are simple steps. Either say print it is full or else 2 steps. So the time is constant. So from the code also you can see that the time is constant. Now next let us look at dequeue operation, that is a delete operation. Now delete operation. Function name is a dequeue, that is for deletion, and this is having a pointer to this variable or this object. So when you call this function, you have to pass that as parameter, and this is called by address or reference. Now for deleting, I have taken some variable x and it is initialized to -1. Now let us write down the steps. Before deletion, what I have to do? Before deletion, check whether there are some elements or not. If there are no elements, we cannot delete. So when there are no elements means it is empty. So what is the condition for empty? If front and rear are equal, we cannot delete them. So if front and rear are equal, it is empty. So first I should write down the condition that if front and rear are equal, so whose front and rear? Q's. So I can access this using arrow operator. Q's front and Q's rear if they are equal. So say if Q's front is equal to Q's rear, then I should just display a message that Q is full. Then here I just display a message that Q is empty. So printf Q is empty. So Q is empty. If front and rear are equal, Q is empty. I cannot delete any element. Else, how to delete an element? So for deleting an element, just move front pointer to a next location and take out the element. That's all. So how to move front? This front I have to move, so that is Q's front plus plus first of all. So Q's front is moved. Q's front is moved. Then from that place I should take out the elements. So I can take out that element in variable x. So inside x I am taking out the value from Q's Q, that is Q's Q, that is array. From that array, from which place I am taking out the value? So Q's front I am taking out the value. It is taken in x. Now finally return x. So outside else I am writing return x. So the value that is deleted is return. What happens if the Q was empty? So that x will have -1 and nothing is assigned to x. So it will return -1. So if this function is returning -1 means Q is empty. There are no elements in a Q. So that's all. This is a dequeue function. And if you look at the function, the steps are very simple. Condition is checked and the printing is done. Otherwise, just 2 simple steps. So the time taken by dequeue is constant. So from the code also you can see that it is constant.